Okay, good afternoon, ladies and gentlemen. My name is Michael Gaunt, and I am here to talk about the implementation of BIM on a large infrastructure project. Okay, so as I say, my name is Michael Gaunt. I'm a chartered engineer, and I work in London, England. I'm a tunnel engineer, and I focus in the power and water sectors. So I'm coming to talk to you this afternoon about BIM from an engineer's perspective. So I'm interested in how we look at the models, how we use the models, how we check that the right information is in the models before we give it to the clients. So just a bit on the company that I work for before we go any further. The company's called Mott MacDonald. We're a global management, engineering and development consultancy. We've got over 16,000 staff across the world. And one of the things that we're focusing on as a company is to bring BIM into all of our projects, because we believe in the efficiencies that it brings and the benefits that it can bring to both us as designers, our clients, and whoever's going to actually use the designs that we create. So what I'm going to talk about today, I'm going to start to talk about an introduction to the project that we're working on. Then I'm going to talk about planning and implementation of BIM, something that we might not have done 2 years ago, but what we see is really key now and what we would have done and what we do on all our future projects. I'm also going to talk about some of the challenges of BIM, and then finally talk to you about the benefits that using BIM on our project has brought. So the project is called the Counters Creek Flood Alleviation Scheme. It's a flooding scheme, so we're trying to remove flooding from over 1,700 properties in West London. The scheme is hopefully will start construction late next year and then go through to somewhere in the region of 2020. We're not that far down the design line yet to understand those fully. The scheme's made up of 5.2 kilometres of 4-metre diameter tunnel, and it's approximately 30 metres underground. It's got one main large tunnel drive site, which then will intercept a number of smaller shaft sites through the London area, and then we've got another 15 sewer upgrade schemes. So that's really key in terms of BIM implementation on the project, because we've got this one large project, and we've also got lots of little projects. So the processes we develop and use have to be scalable, work both on the large project and also on all the small projects. So I don't know how well you know London, but this is kind of West London. Over there we've got Buckingham Palace, you might recognise. We've got Hyde Park at the top. And we're working over here in West London. So our tunnel will be driven from this point here and will continue up to the north, intercepting a number of points along the way. And we've also got lots of smaller schemes in that area. So using BIM and the visualization element of BIM is absolutely key, because this is a very dense urban environment. There's no places to obviously construct a tunnel. We have to use our innovation. And by using these models, we're able to show our stakeholders, show the community, show the people who might be affected by this construction exactly why we're doing it and why we need to be in their areas. And hopefully by engaging them through the visualizations, they can gain a better understanding and we can work with them better. So I'm sure you've heard in many of the presentations today that BIM is all about the life cycle of the project. At the moment we're at the end of stage 3, which is develop design. So we've got a concept, but we've not got too much detail into it. But we're aware that coming from stage 0 through to stage 3, that planning is absolutely key on a BIM project. So what we're looking at now is we're looking through to construction and operation. We're trying to engage with the contractor and say, you know, what information do you need from us in your model? How does the client want to use this? How is it going to be passed over to his operations team? What information do they need later down the line to be able to run this project? And hopefully by engaging at this point in the design, we can have efficiency savings as we go through the project. So in terms of the project then and the common data environment, this slide's just to show you the amount of people that are working with this information. So we've got over 150 people working on the project at different times, over 15 companies, and that's increasing every day. So the use of the common data environment, so everybody's working with the latest information, is absolutely key. And that's where some of the huge efficiency savings that we're seeing are coming from. We haven't got it perfect at the moment, but what we've got is much better than what we had 2 years ago. So people can get access to that information straight away, and we don't have a designer 6 months down the line, and another part of the design 3 months behind. We're trying to all move forward together, and BIM brings that benefit. Okay, so I'm going to go now and talk a little bit about planning of a BIM project. So the first thing that we need to look at, and we need, is the employer's information requirement. So I've broken this down into technical, management, and commercial. And what we've got on the screen here are just some of the items that should be considered to go into the EIR. Now, the employer's information requirement is a key document that you've already heard about today. But we're finding with some of the clients that we're working with, this document, it can take 2 years to engage with everyone along the process to understand what information they need, so that you can then go back to the start of the project and say to the designers, right, we need you to consider this, we need this information so that we can pass it on to the next stage. But a really key document. The next document, which could be part of the employer's information requirements, is the model production delivery table. So what we've got down the left-hand side is the different disciplines. We've got the companies that are producing these models, and then we've got who is the key owner. What we've got on the right-hand side there are just some examples of data drops. So you've got the REBA 3 drop and the REBA 4 drop. That's got to tie into the program. So at those stages in the program, when you finish those stages, what information does the client want? And as an engineer and a consultant, what information do we need to deliver? So if we just pick the shafts, say, for example, Mott MacDonald are going to be producing that. They're going to be producing a level of detail 2 and a level of information 0. So that's the scope of work. So if I'm in the shafts team, that's what I need to produce. But what exactly does that mean? Well, here's a few examples of level of development. So level of development is made up from level of detail and level of information. I've taken this from the NBS BIM toolkit, which is freely available online and has a wide range of definitions of level of development. But as you can see at stage 2, all we need the tool to be is a straight line. We don't need to add any more information at that stage. There's probably lots of changes, so there's no point developing a detailed model at that stage. When we move into stage 3, we're starting to add a bit of information to the model. We've got a 3D model at this stage because we're starting to get more confidence in exactly what the design is going to be. And then we move forward into stage 5, which is just for construction. We've got lots of information in, but we need to know what information we need to put into our models so then we can start working on it. Next thing that we need to look at is the engineering technology assessment. So to produce that model, whatever it might be or whatever the specification is, what information are we going to get, and what do we need to produce for our client? What format does it need to be, and how are we going to get to that format? So we could use a variety of software, as you've seen today from Autodesk, but what is the most appropriate to be able to produce our information out? And that's a key part of the planning process. So the next thing is to build our engineering technology assessment into the common data environment. So this is a BS 1192 structure. We've got work in progress. We've got shared areas for our separate companies. Once this external company 2 is happy with their information, they can push it through to the project shared area so that everybody can see that information, then finally published. But we need to understand what that structure is. And that's probably that will be based on the contractual mechanisms. But once we've understood that, we can then define that in our common data environment. So then we need to map the software we're using into the common data environment. So we've got work in progress, our shared areas, and our published areas. I'm going to look at, so what software we're going to use. How are we going to get from our work in progress area to something that the client can look at? It's not good in just saying, oh, we're going to use a Revit model the whole way through, because the engineers need to be able to check the model. What are they going to use that? Well, maybe they'll use a Navisworks model. What do other disciplines want from us? Do they want a Revit model? Do they need something else out? It's something that we need to consider. So do we need to, in the shared area, to check the information, do we need to be producing drawings, maybe a PDF? As long as we know that up front and we've planned for it, that's fine, but we do need to plan for it. Final thing to understand is where the information is going to be stored within the common data environment. It can't just be a dump of information into that area, into that cloud, whatever it is. It needs to be structured in there so that everybody knows exactly where to go for that information. And on a project where you've got 150 people looking for this information, it needs to be clear, it needs to be in the right place. So planning is key at the start. So One of the things talked about from my point of view as an engineer is assurance. Great, we can produce some 3D models that look brilliant, but how do we check that the right information is there? What we've done is we've used Navisworks to mark up the design as we go along. But we need to build that into the process because to meet our company's insurance requirements, we need to store that markup somewhere to show that we have checked and applied a level of detail and a duty of care to that model. Again, it's all things that need to be considered. So then going back to the common data environment, once we've done all of those previous elements, we now start to need to consider roles and responsibilities. And that's absolutely key for using a BIM project. Who is going to be responsible for checking the models? Who's going to be responsible for approving them before we push them through to the shared area? If we're working with drawings on the table, well, it's fine to be able to say, oh, well, he's free. I'll pass the drawing to him to check. But actually, in this situation, we need to build it into the software, so it needs to be black and white. And what you're now starting to see is that BIM is actually your design management tool. It's your design management process. It's not something you can just bolt on at the end. It encompasses everything. So when someone comes to me and says, what's the cost of doing BIM on that project? Well, I actually need to step back and say, well, BIM covers every little aspect of the project, and you need to consider it. Another thing which we found is often not considered at an early stage in the project is the hardware plan. Do we have the software, do we have the hardware, the computers to look at these models? Do our project directors have the laptops so when they're abroad they can check a model? Are we able to send information to all these offices over the internet? Is the internet link there? These are all things that we need to consider at an early stage before the project even starts. We've learned this on previous projects where the first 2 weeks of the project actually we can't get the models quick enough to other offices across the world. So we need to consider that. Once we've considered it, we can plan for it, and then when we implement and start the project, we can start straight away on a strong foot. Okay, so what we talked about is the employer's information requirement at the top, coming through to, you have to bear with me a moment because my Russian's not too good. So the employer's information requirements at the top, moving through to the technology assessment, what software we're going to use, how are we going to use it, how are we going to check these models. Then we'll look at interoperability and protocols. How do these software talk to each other? If we've got a different discipline using a different software, how are we going to send it to him? How are we going to send it to the client? What software is the client using? Looking at the whole life cycle of the project. Then coming through to assurance, how are we going to check the model? Moving on, we develop a workflow, build it into the common data environment, and then look at the hardware plan. And then the final item on there is the program and pricing plan. So once you've done all that, then you now know what you're going to be producing in your models, how you're going to be producing it, and then you can price for that and give a price back to the client. And then that program then ties back into the employer's information requirements and that model production delivery table so you can see when you can produce your models and at which stage. And then, once you've done all that, you can write that in the BIM execution plan. A key document, a live document we found on all of our projects, but that document should be able to be given to anyone working on the project, and they can straight away open that document, and they can see how we're going to do everything on the project. All the workflows are in there, so they're not going to just take it away and do it their own way and not produce what we want. Everyone's working the same way to the same common goal, and that's a really key document to be able to produce. Okay, now, so coming on to some of the challenges of implementing BIM, it's not just a case of taking the software package out of the box and implementing it. It's a real culture change. This slide is talking about training and BS 1192. BS 1192 is absolutely key, but everyone needs to understand it to understand how it works and why it is so important. So BS 1192 requires on the early sharing of information. But what we've found is that traditionally, engineers will wait till the design they've got is right before they pass it to anyone else. What you're doing with BS 1192 is pushing information from the work in progress area through to the shared area, but putting on it a tag to say, well, I'm 20%, 30% confident on this information. I've pushed this information through for a specific reason. So I might push it through and know it's not perfect, but I need to push it through so that all of the other disciplines can start working. Now, we found that that's a real challenge to educate people to understand why they need to do this, which improves the efficiency of the project, is one of the key challenges of implementing BIM. One of the other challenges we've come across is the fact that engineers and the client as well do not get a physical handover of a drawing. They actually just get this digital model which is on the computer, so they don't necessarily feel like they own it. Again, that's training is required, education is required, and we know when you're working across huge teams of people and across many companies, that's a key aspect that you need to consider, because that training needs to happen at the start. It's one of the situations we've had is where we work on the project for a year and then we find out a number of colleagues aren't happy checking a model because they're just not comfortable using the software. So suddenly we've got a barrier to how we move forward. It definitely needs to be considered at the start. So, this is just about leadership. It was mentioned earlier in the discussion at the start of the conference. So, implementing these processes relies on the people. Yes, software is part of it, but if the people aren't prepared to take it and run with it, it just doesn't work. You can't have 5 people being experts in it and the rest of the project not understanding it at all. So it relies on the common data environment, the people, and the trust. People have got to trust that if they push this information forward, it's used for the right reason, and they have to trust that everyone else on the project knows that. Leadership is key. If you don't have leadership from the very top and saying, look, you have to do this, people will revert back to their old ways. It doesn't matter how good you try to implement it, the amount of documents and workflows you produce, you have to have that leadership to say, come on guys, you're coming with me, we're going to do this and we're going to do it right because we believe in the benefits it brings. In the UK, we've definitely got a big government drive. It's mandated from next year, and that's really helping with everyone to say, you know, actually, we do need to do this. And then sharing lessons learned. One of the big things we've got to do is we have to keep going around the company saying, what have you done here that's worked well? What have we done? And then hopefully we can bring each other up together. Talking to our clients and saying, you know, we did this well on another project, shall we do it here? Have you thought about this in your employer's information requirements? Everyone needs to talk to bring each other up. Okay, so this is just looking at some of the outputs that we've produced on this project. So what we've done, we're a tunnel project, so we've used Civil 3D to model all of the underground utilities in London, so railway lines, sewer lines, power cable tunnels. Once we've done that, we can very easily see where we can knit our tunnel through with all of these areas. We can see where the issues are, where we might have clashes, where we might be very close, and using this software to do this has brought huge benefits because we can look at many options very, very quickly. This area beneath London is very densely populated, is not the word, but lots of tunnels beneath London. So feeding it through is a very difficult job, and this software means that we can actually do that. So again, use of Civil 3D. We're in an area, a dense urban area here, lots of houses around. By modelling everything in Civil 3D, straight away we can see where the issues are. We can see where the risks are, where we're very close to crossing tunnels. So we're identifying that risk very early on in the project. We can let our client know. We can improve the design. If we can't improve the design, then what we can do is say, right, we've only got so much money for survey information. We can go out and we can target key areas and say, this is where the money is best spent. By doing that, identifying the risk at an early stage, it's okay to make errors in the virtual environment, but let's make them in the digital environment before making them in the real world. So we've used Revit to model all of our connection shafts at the end of the tunnel and the points where the water goes down into the tunnel. This is the pumping station shaft on the edge of the River Thames. It's a very complicated structure, and we've got many disciplines that are working together in that area. So by applying BS 1192, bringing everyone together, we can produce a design where we know that everything's compliant. We've met the client's level of detail, because he said, we don't want lots of detail in the shaft walls, say. We just want the outline of the shaft, because at this stage, that's all that's needed. Using Revit and this kind of software, because that's what we've picked through our engineering technology assessment, has brought many benefits. And a side product of that is that you can actually get in, you can see. The operations staff can come, they can actually look and say, well, actually, I'm not happy with that. I'd rather you change that. But we'd rather make that change now, at this early stage, rather than wait for it to be constructed, and then we realise that we've got an error. So again, talking about the life cycle of the project, once we've completed these models, they're going to get passed over the contractor to construct them. Getting the contractor in early board and looking at the construction layout, the temporary works layout, how is he going to get his ships near to the construction site? If we can identify this at an early stage, reduce the likelihood of rework later on, reduce the risk in terms of maybe planning, because people can see what's happening, and therefore we're saving costs, because change at this stage of the project is cheap, change later on in the project is very expensive. And then we've used InfraWorks. So by bringing together all of the tunnels we've created in Civil 3D, the Revit structures that we've got, this is buildings from a GIS building layer, all at the right height. We can visualize the area. We can show people what we're trying to do, and then we can talk about it, and we can make sure that we're all on the same page, because looking at a 2D drawing or just discussing, there might be areas where you can miss things. With these visualizations, everybody can very quickly understand what we're trying to do. Very useful tool. And then going back to Civil 3D in terms of our outputs, so we're producing drawing outputs of where the tunnel's going to go. Once we have produced this and set up this template, the Revit files go straight onto the long section. We can see where the crossing tunnels are, which is all automatic. We can also see where the ground layers are, so when we're going through clay or sands or chalk, that's all highlighted on there. And we can quickly understand the impact of a change, and then if we want to make the change, we make it in the model, the drawing updates very quickly, and then our output's done again, rather than starting again from scratch. Okay, so again, just a bit more on visualization. From an engineer's perspective, the most important point of the design models for me are you can see it on the screen, you can pull the information off very quickly, develop the design very quickly, but the visualization element is also very important. So here we used the gaming engine, and we took our models, put them into the gaming engine, and then the public can come along, they can basically play with the gaming engine, they can see the impact that construction is going to have on their area, and once they've understood better what the impact is going to be, they can talk to us, understand why we've done it, and hopefully we can then get them on board quicker, so we can hopefully get through the planning process easier. Another example where we're trying to use our models quite innovatively, we're looking at augmented reality apps with a company in London. So we send them our design models, and then through the use of an iPad or an iPhone, the model appears on the iPhone, and then again, it can help with people to actually engage into the model. So rather than come to a church in London and look at some drawings on a wall, you can actually use this and really get into the model and really understand it. Okay, so talks about assurance, checking the model. Using BIM and the BIM tools gives if you plan it right, means that you can get a much greater degree of assurance. So the client, rather than him seeing at the end of the day what we've produced in the design, well actually he can come in every week, he can come in every 2 weeks, he can sit with us, and he can see what our models look like. And at an early stage and go, I'm not happy with that, please can you change that? And then when we get to the end, he can be confident that what we've produced is what he wants. And also we can be confident that what we've produced is what he wants. A very important part of it. And again, that's bringing the collaboration together, because more people are looking and working with the models. This picture on the right-hand side, although it might not seem as snazzy as the previous ones I've had on the screen, that's my design team, that's my project director, actively getting involved and using the model. Now, a year and a half ago, that wouldn't have been possible. But they've now seen the benefits, they've now gone through the training, understand how to use the software, and they're all actively on it. So it's not 3 people in a corner using this software, it's everyone on the project team is actively using it. And again, the more people that get involved, the more efficiencies we can achieve, and the greater the benefits become. On the left-hand side, I've just noted out our little operations man inside the shaft. So again, at an early stage, we can look at and say, right, these are the people who are going to be using this structure. How are they going to get in there? How are they going to maintain it? We can show them models like this, so they can look at it and straight away they can say, not happy with that, please change that. We've looked into using the Oculus Rift goggles so they can really get into the model. And that's something that would never be possible with the old way of working. So, in terms of the benefits of using BIM, one of the greatest one for me is the control of change. So this picture is West London. It's the area that we're trying to tunnel beneath, and it shows all of the options that we've considered on the project. That's a huge amount of options, and I believe that that would never have been possible if we hadn't have used these processes. So by using these processes, using these software, we can look at a vast amount of options and make sure that we're picking the very best option for this area, minimising the impact on the people there, maximising the output for the client. So just to summarise then, on this project we believe that we've gained maximum benefit because we understand how important it is for planning. I can't read Russian, so I can't tell you the next bit. Just wait me one moment. Okay, so we've taken significant benefits because of careful planning, which has reduced the risks. It's improved collaboration on the project, but it ultimately relies on training and the people that are going to do it. I'm not standing here and saying that we've got the perfect BIM project. We're very, very far from that, probably. But actually, over the past 2 years that we've been working on this project, because we've been pushing hard, we now understand why these standards have been created in the UK, why the government is driving it. We understand the impact of planning and the benefits that that can bring, which means that ultimately our project is improving in efficiency. Hopefully we're reducing costs by looking at many design changes for the same costs previously. And we've engaged the rest of the life cycle, so that now when we've got the design model, we're confident that the contractor is going to be able to use it. We're confident that the operations staff are going to get the information they want. And we're confident that the maintenance team will be able to get in there and use it. So ultimately we can be much more confident with what we've produced because of the tools that we've used. Thank you very much.
You don't have translation, yeah? Okay, I'll translate for you. Oh, okay. Sorry.
While you work with this project, what was the technology of transferring information between parts of your project, between different specialization? Did you use some kind of internet services, or it was some local software? Or if you use both, what is the main? What was the main?
The common data environment was stored on ProjectWise, and that was because of our engineering technology assessment at the very start of the project. But in terms of bringing the models together and reviewing the models between disciplines, we used Navisworks. So all of the models came together in Navisworks, and we could then see how one discipline impacted on the other discipline. We marked it up on Navisworks, and then the modelers went away. But yeah, the common data environment was on ProjectWise, which is internet-based, which moved the information between the departments, and that was because of the engineering technology assessment.
Еще вопросы? Где-то были, по-моему. Вот, хорошо.
We had more.
Thank you for your presentation. Here comes my question. When you developed your project, you had information about a large number of underground communications. Where did you get it? In Russia, we have a big issue with that. In most cases, we don't get this information. You had it in digital form, or did you have to digitalize it using paper maps?
So much for your presentation. And the question is, when you created your project, you used a lot of information about underground communications. Typically in Russia, we are having a lot of problems with getting this information. Where did you get it from? You had it initially in paper and then made it digital, or you had it initially somewhere in digital form, or how?
Okay, so in terms of the underground information of the existing tunnels, the utility companies own that information. We, as a consultancy, we don't keep that information. The information was passed to us in paper format, and we then have to draw up that information from paper into digital. I mean, that's a huge amount of time to do that. But once we've done that, and we'd have to do that in our old way of working anyway, once we've done that, we can then say, right, okay, we understand that that process wasn't perfect, but we can then say, right, this bit of information, we've only got 50% confidence in it. We can put a larger buffer around the tunnel in Navisworks. We can then identify the areas of risk, and then we can go away and say, right, we want survey information to accurately identify where those tunnels are. We're now at the stage where we've done that, and a survey company will be going out in the next couple of months, and I understand that they'll be using little ships to go down the sewer. They'll be taking radar point cloud scans of the sewers, very accurate information in certain areas, which can come back, again, further reduce the risk of a clash of our tunnel, and then we can progress the design from there.
Okay. Еще вопросы, коллеги? Я не вижу. Так, давайте туда.
Добрый день. Такой
Did you get paid for converting all that information on communications and talents into a digital form?
Transferring from paper documents to digital documents.
We started the project about 2 years ago, and from the very start we said that this was going to be a BIM project, and that's coming back to the leadership piece. So at the very start, our leaders, our project director said, no, from the very start we're going to be using 3D models, digital information. Some of the information we get in is in paper format, but ultimately we're all working in a 3D environment from the very start.
So there was no specific payment for transferring information from paper to digital. It is within the project.
If we need to do that as part of our process, then we will build it into our pricing plan, and the client will pay for it. Yeah.
Скажите, пожалуйста, со стратегической точки зрения.
From strategic standpoint, how important is it to know upfront all the stakeholders in the project, the construction organization, design organization, and the operator to properly implement the project?
Point of view, how important it is to learn all the participants of the project from the very beginning. It means the design organization, the building organization, the owner of the final project.
I would say that from reflection on what we've done, it's very important. That understanding what the user wants at the end of the day is all about BIM, because it covers the whole project lifecycle. Therefore, it's very important. We're seeing some of our clients are understanding this now, and they are bringing organisations into their organisation to go around and speak to every person who is affected by the project and say, what do you want from this? Then you can create a much better employer's information requirements, clarify it from the start, and then everybody's much clearer as you go forward. The cost of that compared to the cost of producing something that's unusable at the end of the day, although you need to budget for it up front, I think is a very worthwhile spend.
Thank you. Еще вопросы?
Мне показалась интересна ваша фраза о том, что только спустя 2 года...
Your statement that 2 years after implementation of this technology, you realized that you should use it. Why did you come to understand that so late? Can you explain that a little bit?
The question is that you say that only after 2 years from the project beginning you understood why government demanded from you demanded BIM usage from you. The question is, why did you understand it so late? Why it took you 2 years to fully understand?
I'd say that certain elements of the project understood it at the start after 3 months, say. But many of the UK standards that we're working to haven't been around for 2 years. There's a huge learning curve that we're going through in the UK to be able to get to our mandate for BIM next year. And also that goes back to the training piece, because even though some people on the project understand exactly why after 3 months, you need everyone on the project to be to that level. You're only as strong as your weakest link, and processes like this, which are black and white in digital form, show that. So it's 2 years for everyone on the project to bring their learning up, and to be honest, I don't think we're there yet. We've still got a long way to go. We give out capability assessments to, well, we're trying to give out capability assessments to every company we work with, and the range in maturity is vast, and only when everybody comes up is there's a maximum benefit available.
Еще вопросы есть? Okay, thank you, Michael.
Thank you. Спасибо.